Welcome back. In this video, we're going to take a look at the two types of procedures available in the Visual Basic programming language. If you saw the earlier videos covered the fact that procedures exist for Visual Basic. They're named blocks of code that accomplish a task. And we took a look at some procedure examples where they were defined as type sub. So now let's take a look at the difference between sub and functions. Sub procedures do not return a value back to the calling procedure. Recall the whole point of creating a procedure is that you can call it from somewhere else. Now all our examples so far have called procedures from main. So both sub and function procedures can be called. The difference is that sub procedures don't pass anything back, whereas function procedures do pass a value back to their calling procedure. So a function is a block of code that performs some task and returns a value back. It can only return a single value. So we're going to see a few modifications in the syntax for function definitions. One, of course, is the keyword sub will be replaced with function, but we'll also see the addition of what's called a return type. It's going to indicate the type of data returned from the function. And the return type can be any of Visual Basic's built-in data types, as well as class types. And that's something that's beyond this chapter, a little beyond the course, although we will touch on classes in the next unit. But for example, we can create a function that returns a double or a string or an integer. So we're going to take a look at an example we saw earlier in the programming logic book. This program prompts the user for a number of hours that an employee works and then calculates some things. It calculates the gross pay based on the hours and pay rate. So, of course, all these steps are fairly short, and really, in reality, they could have all been written in submain. But we want to get our feet wet creating procedures and executing them so that we can understand how all this works in a smaller environment. So we're going to create a procedure called getHoursWorked that's used to prompt the user for the number of hours worked, convert it, and then pass the value back to main. So let's see how that works. So here again, we see our sub main representing the main sub procedure. This is going to get executed when the program begins, and it defines two variables and a constant. The two variables are going to be used to hold the user's input of, the first is going to be used to hold the number of hours. Gross down here is actually going to be used to hold the value of a calculation we're going to do. And then pay rate is a constant that's set to 12. So basically, to jump ahead a bit here, gross pay is set to hours times pay rate. So instead of prompting for hours, reading it in main, we wanted to practice calling a function, and recall that a function is able to execute a block of code but return a value back. So here we're calling a function called getHoursWorked, and getHoursWorked has to be defined elsewhere in our program. So we do have it, it's down here at the bottom, and we'll take a look at it shortly. But getHoursWorked is being called, also called invoked right here. Now it turns out, because we were actually going to prompt for enter hours worked within this procedure, we didn't need to pass any information to get hours worked for it to do its job. So notice the empty parentheses. We're not passing any arguments. But something new. To the left of get hours worked, we have an assignment statement, hours equal. And recall that functions like get hours worked return a value back. This is similar to input box or console.readline that receives information from the user and then we assign it to a variable on the left. Same concept, get hours worked is going to get the hours worked from the user. Here we're assigning it to a variable. So the difference when you use a sub versus a function is to remember that a function returns a value. And either we're going to use that value in a calculation, an output, or here we're assigning it to a variable so that we can turn around and use it in a calculation. So for this to work, let's see how this thing is defined. Down here, we have a function. The syntax is extremely similar to using a sub procedure that we've seen in the previous video. The difference is the keyword sub is of course replaced with function, no surprise there, but there are two additions. After the name of the procedure and the parameter list, which again is empty because we're not passing anything in, we have the data type. So this as double specifies the return type. So since the type of data that we're going to pass back to the user is of type double to represent the number of hours worked, we have to use as double. If we were passing back a string, this would have said as string. So inside of this procedure, we define a variable work hours string, and we read in and using input box, we send the user a message, please enter out hours worked. User types their hours worked, and we assign to a variable work hours string. These are the same kind of steps we would have done if we were executing this inside of submain. So we're prompting in the usual way, we're assigning to a string. The difference is we're going to take that string and convert it to a double as we normally do, but instead of assigning it to a variable, here they've put the keyword return in front of the conversion. What this is going to do is it's first going to convert work hours string to a double, and then that double value is returned. So the return statement basically indicates return this value, pass it back to its caller up here, and then in this case it will be assigned to variable hours. If you're asking yourself, could this last line in the function have been two steps? Could we have defined a double variable and maybe called work hours and set work hours equal to convert that to double work hours string, and then said return work hours? Absolutely. They combine two steps here. It is important to realize that they could have calculated and assigned to a variable and then returned that variable. So there are multiple ways to do some of these things. Note that the return type there is the as double. Let's take a look at another example. We had looked at an example using, calculating the tax. So prior to this, our compute tax procedure was used to compute the tax and display the answer to the user. Now, compute tax both did the computation as well as output the value. But let's say that we want to make compute the tax, but not output it, instead pass it back to its caller, because maybe depending upon where it's being called, it may want to output that information in a different format, or maybe it doesn't want to output it at all. Maybe it wants to calculate it and save it to a database. So let's make compute tax just compute the tax and pass the value back to its caller so that its caller can use it as it wishes. So let's look at the bottom first. Here we have our definition of compute tax. You're going to see so many familiarities with an earlier video. We have the name, a parameter list. This particular function procedure requires two parameters, so we have a comma separating the two parameters. The difference between this and the earlier video is that instead of a sub, we've made it a function. See the keyword function here and here. And we're saying this function is going to return a double, because what we're going to do is we're going to return the tax, and tax is a double data type. So inside of compute tax, we create a variable of which to hold the computation's result, and we set tax equal to the amount times rate. The difference is instead of outputting it directly, we return tax. So if the tax is 7, 7 is what's passed back to whoever called compute tax. So let's see how it's used in main. Main starts out in the way that we've seen before. We have a few variables for balance and rate, but we also see a variable for tax here. We did that because we're going to need a spot to store the result that we received back from our call to compute tax. And that'll become a little clearer as we see how this unfolds. So we're going to ask the user for the balance, we're going to ask the user for the rate, we get that information, and then we call compute tax to compute the tax. And as we've seen in previous examples, the order of these arguments in between the parentheses is important. They need to be in the order in which we've specified them in the parameter list. If the balance represents what we're calling amount in the parameter list, then it must be listed first because they're going to be passed in the order in which they occur in the list. So here we're passing balance and rate, two arguments to compute tax. At this point, main's execution pauses. We jump down here to compute tax and we do the calculation. We assign the value and then we return it back. The interesting thing is, since compute tax is a function, it's going to return a result such as 7. And we need a spot to put that result. So that is where our variable tax comes into play. We're setting tax equal to what is received back from compute tax. And then finally, we just output tax along with the rate and the balance. This is very, very similar to the example we just looked at. In fact, the function definition down here is exactly the same. The only difference between this example and the last example is that we've identified that we really didn't have any need to retain tax in main. We were really just using it to display an answer to the user. So whereas in the previous example, we assigned compute tax to a variable, which would allow us to then refer to that variable throughout main, here we called compute tax here right inside of the write line. So what happens is this: when we get to this long statement, the last piece of main, the parentheses work inside out. So we're going to go in here and call compute tax before any of this is displayed to the user. So it calls compute tax, passing the balance and the rate, knowing that this piece right here will execute and return a value. So again, we'll go with 7 as the tax. So let's say it returns a value of 7 here. Then 7 is what's going to be appended to the rest of the data. So it has the amount and then the actual balance amount, the word rate, and then the value of rate, the word tax, and finally the actual tax value. So this does show you that functions don't necessarily need to be used in the context of an assignment statement. They can be placed in other places. Just understand that they are always going to be returning a value back to the user. I'm sorry, back to the caller. And in this case, the caller is main.